Hi, I'm Dr. S.K. Bushra, former HOD, Department of Physics, Cotton University. This is the first of a series of lectures for class 12 science students. The topic is electrostatics. The chapter 1 contains electric charges and fields. Lesson 1 is on electric charges, and this is part 1 of the lesson 1. In this part, we look for answers to the following questions. What is an electric charge? Which are the fundamental electric charge carriers? First thing first, what is an electric charge? Perhaps you are aware that there are 4 types of forces in nature. The 4 forces of nature are gravitational forces, electromagnetic forces, weak forces, and strong forces. We need not bother about the weak force and the strong force at the moment, but our information about the gravitational force and the electromagnetic force will too. Let us recall what we have learned about the gravitational force in class 11. First, the law of gravitation. The gravitational force between two bodies is G into m1 into m2 divided by r square. Here, G is the capital G and is a constant. It is called the universal constant of gravitation, whose SI value is given here. R is the distance between the bodies, and M1 and M2 are the masses of the two bodies respectively. Next, weight of a body, that is the force of gravity. Weight of a body is W equal to mg. Here G is written in small font. Small g is the acceleration due to gravity. Its value at the surface of the earth is 9.8 meter per second square. And m is the mass of the body. In the last 2 slides, the concept of mass has been used. The mass we have been talking about is in fact the gravitational mass. Recall that the gravitational mass of a body is numerically equal to its inertial mass, which is defined through the equation F equal to ma. F being a mechanical force causing an acceleration a on a body of inertial mass m. We know that mass of a body is the quantity of matter contained in the body. We may define mass from another standpoint. The mass of a body may be defined as the property of the body by virtue of which it is able to interact gravitationally with another massive body. Let us now enter the domain of electromagnetic forces. We note that electrostatic forces are only a subset of electromagnetic forces. In class 10, you have learned something about electrostatic forces, including Coulomb forces. You are aware that these forces have characteristics which are quite different from those of gravitational forces. Let us now ask the question. Under what mandatory condition would two bodies interact electromagnetically? The answer to our question is the bodies will interact electromagnetically only if both of them possess a particular intrinsic property. The name of that property is charge. Thus, what is gravitational mass to gravitational forces? Charge is to electromagnetic forces. Next inquiry, where do bodies get charged? Rather, how do bodies get charged? To know the answer, we need to delve into the microscopic level, that is to the level of atoms. as most of the charges of the universe are carried by two subatomic particles, protons and electrons. Let us now enter the world of an atom. Atoms are the basic units of matter, and they define a chemical element uniquely. It is a composite body. It consists of a tiny nucleus and orbiting electrons. Size of an atom is of the order of 10 to the power minus 10 meters, that is 1 angstrom. Size of a nucleus of the order of 10 to the power minus 15 meters, that is 1 Fermi. Two types of particles reside in the nucleus. They are protons and neutrons. Mass of a proton is 1.6726 into 10 to the power minus 27 kg. And the mass of a neutron is almost equal to that of a proton. Protons carry charges, so protons are capable of taking part in electromagnetic interactions. The magnitude of proton charge is 1.6 into 10 to the power minus 19 coulomb. The neutron does not possess any charge. A proton and a neutron will therefore never interact electromagnetically. However, they will interact by some other mechanism, providing stability to the nucleus in the process. I put an asterisk marks at the end of the sentence here. The number of protons in the nucleus is the atomic number of the element. The total number of protons and neutrons in the nucleus gives the mass number of the element. Coming back to the asterisks, we'll revisit the role of neutrons inside the nucleus in a subsequent lesson. Another type of particle, called electrons, orbit around the nucleus in some selected stationary orbits. I have put an asterisk here also. The electrons orbit around the nucleus to provide dynamic stability to the atom. There is one more asterisk here. Number of orbiting electrons in an atom is equal to the number of protons in the nucleus. Each electron possesses charge of magnitude 1.6 into 10 to the power minus 19 coulomb. This is same as that of a proton. Mass of an electron is, of course, about 2000 times less than that of a proton, and it is equal to 9.1 into 10 to the power minus 31 kg. Coming back to asterisks, we'll revisit the selected stationary orbits and dynamic stability of an atom in a subsequent lesson. In a given environment of electric force, if an isolated stationary proton moves to the north, then an isolated stationary electron will move to the south, that is, in the opposite direction. This happens because the charges held by protons and electrons are opposite in nature. Benjamin Franklin was the one who first chose to call electrons negative and protons positive. He simply made a choice that made sense to him by calling electrons negative. So we have charge of a proton equal to 1.6 into 10 to the power minus 19 coulomb, and a charge of an electron equal to minus 1.6 into 10 to the power minus 19 coulomb. We have already noted that under normal conditions, an atom contains equal number of protons and electrons. An atom is therefore charge neutral under normal conditions. However, an atom may become charged. It is possible to knock out electrons from an atom with addition of certain amount of energy to it. The atom which suffers a deficiency of electrons becomes positively charged and is called a positive ion. An atom may capture electrons too. The atoms which has an excess of electron is negatively charged and is called a negative ion. Let us consider an example. Sodium has 11 electrons, one extra to have an entire shell fixed. Rather, shell filled. Its electronic structure is 1s2, 2s2, 2p6, 3s1. Sodium is too eager to lose that 3s1 electron to have full shells. Chlorine has 17 electrons and is in need of one more to fill his third shell. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Chlorine will be interested to take that extra sodium electron to have full shells. So what happens? The sodium gets rid of one electrons, chlorine picks up that one. The missing electron endows sodium with a positive charge, while the additional electron gives chlorine a negative charge. The positive sodium ion and negative chlorine ion will then bond to form sodium chloride. What about protons? They are tightly bound within the nucleus and are not removable by ordinary means. Protons simply provide the positive background. Electrons carry out the business part by migrating to new homes. We have come to the end of lesson 1, part 1. In the next lesson, we'll discuss the charging of material bodies.